Over to you, Sita. Sita, can you please begin?
Yes, sir. Good
Yeah,
evening,
please.
all participants. I am Mrs. Sita Rajagopalan, Head Client Relations, Explore the Space. On behalf of Explore the Space, North India chapter of American Ceramic Society, welcome you all for this webinar on career opportunities in aerospace ceramic. The keynote speaker of this seminar is Dr. L.K. Sharma, sir, CEO, Mahanama Ceramic Development Organization, and the introductory address is by Professor V. Sumitra Devi, Chief Administrative Officer, Explore the Space, and Practicing Architect and Town Planner. I kindly request all the participants to keep your mic off. Over to Madam Professor V. Sumitra Devi. Thank you, one and all.
Thank you, Sita.
Okay, madam.
Thank you, sir. Thank you, sir, for your presence. It's a short introduction about Dr. Lalit Kumar Sharma. His laurels are very big. Dr. Lalit Kumar Sharma is a renowned ceramic scientist. He obtained his PhD degree in ceramic engineering from IIT BHU. Dr. Sharma is a renowned former scientist of Central Glass and Ceramic Research Institute, Khurja, Government of India, and former president, Indian Ceramic Society. At present, he is the president of the India chapter of American Ceramic Society and CEO of Mahanama Ceramic Development Organization, New Delhi. Dr. Sharma is the recipient of several prestigious awards: Industry Services Award of Rotary Club UP 2008, Shubham Shri Award in UP State 2008, Global Star Award by American Ceramic Society in 2014, Professor M.D. Narasimhan Memorial Award of Indian Ceramic Society 2021, just to name a few. We're extremely honored to have you as the keynote speaker for the webinar, sir. I once again welcome you on behalf of all the participants in the webinar. The floor is all yours, sir.
Yeah, thank you, Sumitra, for nice introduction, and thank you, Venkat, for organizing such a means good, nice conference on this
Yes.
the burning need of the day for engineers and science graduates, science postgraduates.
Yeah.
One thing that Venkat, when somebody wants to join it, displays on the screen.
Yeah,
It is
yeah, we will take care, sir. We will take care.
so. This is a very good topic to talk, and luckily that when you asked me that recently I have gone to US to deliver one invite, just 2 minutes, as you told me my experience. So it was in Florida, Daytona Beach, and 6 days conference of International Conference of American Ceramic Society, wherein almost delegates from almost 38 countries were present, and it was 3,000 plus delegates were there. So, and almost 16 parallel sessions were going on in different rooms. And I had a chance to chair a session, and then I delivered an invited talk in that conference. And this was 49th year conference on international advanced ceramics and composites. The composites, advanced ceramic as well as composites, which have the major role for the success of this space vehicles. This was that 49th year, and next year January it will be 50th year. So they whole year they will be talking about gold seminars all over India, all over world. And president of the American Ceramic Society, Dr. Ferrari, she is from Italy. She has promised to me and that HOD of Anna University Ceramic Technology Department,
Yes.
Dr. Manisha,
Dr. Manish.
and promised us to come to India, particularly to Chennai and Delhi in October end of this year.
Okay.
And
That's very
same
good.
year she is having his birthday, same month,
Okay. Okay.
having the birthday. So
Okay.
she was telling that I will celebrate in Chennai. And
That's very good, sir. She's most welcome.
first time earlier means in the past when she has visited India, so
Yes.
she has come to Chennai only. She has not
Okay.
gone to any other city in
Oh,
India.
I understand.
So this is this thing, and after that I have gone. It was on 26th to 30th. It was there this program
Okay.
in
Okay.
Florida, Daytona Beach, and
Yeah.
after that I have gone to NASA. And
Okay.
on 4th February, I had a talk in NASA in Cleveland.
Okay. Yeah.
Invited
Cleveland.
talk, and they organized my visit to all the laboratories and
Okay.
taken me to so many very means rare places.
Yeah.
They
Yeah.
showed me. So this is
Okay.
about my US visit
Okay. Thank you,
highlights.
sir.
Now I'll come to the topic that
Yeah,
what
sir, I just wanted to ask you about the participation of Indian companies. Were there Indian companies at the ceramic show in United States of America?
there was no Indian company, and as in the end of my talk, I will say that Indian company, India, I can say
Yeah.
India is almost like suppose 3 to 4% of the world requirement of advanced ceramics
Okay.
and aerospace ceramics. So many components. So we are means almost means we are almost nil if we
Okay.
compare other small developed
Okay.
countries.
Which
There were
means, but
no
the opportunity
companies.
is there. Opportunity is there.
Opportunities are there, and companies are coming up that I have talked in the end of my talk.
Sure. Sure.
So that is
Please.
there.
Sure. Thank
Yeah.
you, sir. Can we
So
run your presentation, sir?
yeah. Now we can start.
Yeah. Sam, can I request you to run sir's presentation, please? Yes, sir.
You can make full screen.
Yeah. Sam, you have to press F5. Yeah. Yes, sir.
Yeah. So means participants in today meeting are from different cities, different institutes and universities. So good evening to all of you, and I'm very much confident that presentation will give you good highlights, and it will be interesting to you all because. Good thing is that Sunita William has come back to Earth on day before yesterday only. So I have shared few things which I have seen in NASA, and I have shared related to and same kind of incident which we were expecting has taken place, but we are lucky that she has come back safely. So now it is opportunities on space and allied industries for engineering and science graduates, postgraduate students. Next slide, please. Now we talk about space journey and what we need. It is aeronautical engineers, same thing, astronautical, aerospace engineer, different names, mechanical engineers, electrical background, computer background, electronics background. Electronics background, the suppose someone from science background, even in physics, electronics background, people have the opportunities. Ceramic background, civil background, and food background. Why food I have talked? Because everyone they know that for 9 months Sunita was there in space, and that what food she would have taken, that kind of food that was totally frozen and means dry fruits and vegetables. So that means even peas I could purchase 1 kg for me, and I have brought that here. And I am taking 5-6 pieces daily in the morning with the breakfast. So that kind of food also, food technology also is important for a space journey. Now next slide. Yeah. Now suppose for all of you I am telling the manufacturing of a spacecraft and aeroplanes is one of the most important businesses, and employers in this industry are looking for new graduate engineers to join their aerospace industries, and but at the same time they are looking for, so but there are a lot of skills requirement. It is not means it is easy as well as not so easy, you can say. So that, but there are so many skills. You should be well equipped in problem solving skills, business skills, analytical capabilities, interpersonal relationship skills, communication skills. These are the important. If suppose you miss, you know that for 7 minutes the communication broke with this Sunita William, that capsule. So whole NASA was worried and they were upset. So everything is important in life for to join aerospace engineering. Next slide, please. Space exploration. Now I have come to particularly because it is air space related, so I will cover first aerospace engineering, space exploration, new aviation technologies, design, development, testing, defense systems, aircraft maintenance, spacecraft maintenance, satellites, and missiles. They all come in this engineering branch. Control. Employment in a variety of organizations are available for these people. Navy, RAF, NASA, ISRO, CSIR labs, which is in National Aerospace Laboratory in Bangalore, Defense, Space Organizations, Army, and so many private companies. And it is one of the best career path, and they are well paid, and salary starts from almost 9 lakhs per annum in Indian currency. Jobs, the jobs, it will be common for all the engineers, but here research they need to do, CAD operation, designing, lectures, lecturer job they can do, maintenance, manufacturing job, material selection jobs, mechanical work and electrical works. These are the job profiles available for this aerospace engineers. Next. Next slide, please. Yeah. Now roles and responsibilities are there in these organizations to develop missiles, aeroplanes, weapon systems, spacecraft, create new technologies for these all spacecraft and aircraft, then testing of all these spacecraft components as well as full assembly, proper planning is important, then environmental test, environmental stresses, experiments, operational, all activities they have to check. Then new designs they have to work. In that, even ceramic designers are required, mechanical engineers are required. And I will try to show you the capsule which went in 1971 and which came, the capsule through which Sunita came back looks different. That is role of the designing engineers as well as designers, means NID graduates, writing down reports, coordinating, and then directions given to the down the line, inspections, what kind of damages, means can take place, ensuring various models of the equipments. So all these are the roles and responsibility of all the engineers and scientists and designers. Next slide, please. Then problem solving, as I told in the beginning, problem solving as well as analysis, analytical capability. So to this kind of problems come up, you have to have blueprint for that and how we are going to solve that. If this happens, that happens. All things are worked out because even a 1 minute, 1 second is important for this kind of operations. Design, manufacturing, testing, as I already covered. Then most important thing is the creativity. All type of people, whether electronics, electrical, ceramics, means it should have the engineering properties as well as they keep a design engineer in coordination with all people. They do some creative work, and science and mathematics are the only skills. Some people think that because one is spacecraft or one this thing is the combination of so many skills. So you need people think that science and mathematics is important for this, but this is not true. But it is required. Science and math skills, without being mentioned, should be on the top of the skill set. But this is not the only skill which can make a successful journey for the space. You need to apply a lot of scientific principles in normal industries. Trigonometry usage is almost less. Calculus, which we have studied, I personally I have not used anywhere calculus in my means almost 35 years to 40 years experience. Physics is important, chemistry is important, aerodynamics is important. So you have to be creative in all the aspects. When designing a new aircraft, you need to contribute to the designs and find out what kind of new technologies in each and every spare part and each and every even single component, what kind of designing we can do. And objective always remains to reduce the weight of the means that capsule or space vehicle. Next slide, please. Decision making is very important. It is for all the engineers, but all the engineers have some breathing time to means immediate decision taking process. They have the breathing time, but in this case, in a space journey, decisions have to be very quick and very means positive decisions. So decision is very important. Decision is important on materials also, design also. New innovations are required. Digitization is very important. That computer engineers, electronic engineers, they work on digitization of means journey, aircraft operations, all that. Aerial mobility, it include air taxis nowadays. It will come to India also. New flight technologies like hypersonic flights, air travel time they work, how the speed should go up, then which material should be selected for the space vehicles. Then now like vertical takeoff and landing technology like Sukhoi and drones, it goes vertical and it goes horizontal also. So this kind of aerial mobility is required. Immersive technologies are there. Employees training is important. Navigation systems, military operations, air traffic control, and many other simulations are required. So this is for you all to learn and start thinking. And if you start doing this in your day-to-day life, then it will become your habit. And we say that whatever you do daily for 21 days, it will become a habit and it will give you a great success in future. Next slide, please. Now, this is that nowadays world, now we say that 1 degree temperature has gone up, 2 degree temperature may go up. So now that is high carbon footprints. All the developed countries, they have almost means up to, I can say 60% they are successful. And country like ours, we are still far behind on this. So the space vehicle, it should not be emitting lot of carbon dioxide, all these things. So this to the atmosphere, and then all that we have to think to develop these all space vehicles, because climate change is the biggest challenge for all this. So all these engineers and scientists, they think for that ecosystems. So with the help of technology, this thing, and we can do this. So they look for sustainable designs and technologies and space vehicles for suppose next 5 to 10 years. Biofuels we can be used. That work is going on. So that because that will reduce the carbon dioxide exit, carbon monoxide, all that. Advanced satellite technologies, that lot of that we have to think for that, and lot of satellites are being launched. This thing, and that space activities is, and all those things are required, and that line, that launching of satellites, that is growing day by day. And then at the same time, we talk about nano satellites. Even nano robot has come, which we can, that is also part of the ceramic nano robot, which can take the cancer medicine and go and means hit the target. It will go through our blood veins only, and it will hit the target. So same way, nano satellites are being worked out and ready, and something has come out. Global connectivity can be achieved by satellite based communication. So you are the part of the aviation centers and change the way people transport. So transportation also, air taxis, all those are coming. So all this for you people, you will be going to this route. Next slide, please. Now I'll come to aerospace industry. The opportunity to innovate is there for you. Rewarding salaries are there. Demand is increasing because lot of satellites, all that, lot of space shuttles, all that development work is going on. You will get you will get global recognition because you will be going to so many aerospace zones to to judge the stresses. So then hands-on work, opportunity to work with devices, prototypes, flights. Then you will do risk handling. You will do sophistication, scientific devices development. Then you will be working for passenger aircrafts and satellites. Then you need to have the ability to develop inherent and unique technologies. So science and mathematics background is important. Government and other space agencies in India as well as abroad look all type of engineers and scientists for developing flying vehicles and other systems. So that kind of scope is there for all the engineers in aerospace industries. Next slide, please. Today, as this explore the space, they have told targeted this talk to ceramic engineers, and now I'll come to particularly to ceramic engineers. Ceramic engineers, they need physics also, chemistry also in their means study. So physics, chemistry, scientists also can physics of ceramics, chemistry of ceramics. So those people also are equally important in the team. And you will say that inorganic and non-metallic materials, that is the first definition. Ceramic science, you will say in daily life, fiber optics for communication, what we are getting today on mobiles, microprocessors, solar panels. These are the products of ceramics. Solar panels, light bulbs, jet engines, computers, household appliances, engineered ceramics. Automobiles have the ceramics. Next slide, please. Porcelain wares you use, bricks you use to construct your house, glass you use in your house, glass means toughened glass you use on your mobile, cement is there, tiles is there, pottery is there. Morning you start, you take the tea in the cup, ceramic cup, and you go to do the brush, you go to the wash basin. All that day starts from ceramics and ends on ceramics when you switch off your light. So pottery is there, aerospace is there, electronics, ceramics is there, biomedical ceramics. Now in bioceramics means all that knee joints, eyeballs, all those shoulder joints are made by ceramics because these are very means wear resistant, and these are very smooth self lubrication. There is nothing required for that. And precision ceramics components are there, heat resistance is there, electrical insulation ceramics is there, and overall in so many, suppose in polluting conditions you need chemical resistance. So space exploration, developing materials for spacecraft, develop spacecraft components, thermal protection and other applications, material science, R&D and production. All this not possible without ceramics, and ceramic life also is not possible without ceramics. Spacecraft's development, going to space journey, that is not possible without ceramics science. Next. Next slide, please. Aerospace industry depend on ceramics, which I already told. This ceramic metals, you see, whatever aluminium you take, steel you take, copper you take, zinc you take, which are important in our life. They cannot be shaped without ceramic bricks or containers, or steel cannot be made. Same way, I can say ceramic materials have the very high temperature tolerance, and it goes when steel stops at 1450, copper at 1200, aluminium at suppose 850, 900. So all these metals are melted in ceramic pots. Now I will say that this capsule which has gone, in which Sunita has gone to space, it was when she entered into Earth, means Earth or orbit or Earth range, she was to enter. So the temperature of the space vehicle was 1900 degrees centigrade. 1900 degree. Inside all is metal, outside everything is ceramics. 1900 degree, you can see in suppose Chennai or Delhi, 45 degree. If it goes to 1 degree is going up, we cannot tolerate the summer. So it was 1900 degrees centigrade and the speed was 28,000 miles per an hour. Same time it has communication has broke for 7 minutes, and NASA people who were controlling this whole event, they were totally upset for 7 minutes. And 7 minutes is not a, for us it looks it is a very small, oh 7 minutes is nothing. But single minute is important, even you see the speed. If we say that it will, if we count it in kilometers, it will come to almost 40,000 kilometer per hour. So ceramic thermal barriers were there, coatings were there on aircraft engine as well as on the surface of the this capsule. Composite materials. I will show you in my some photos also, which this came back. The capsule came back in 71. So composite materials were there, ceramic material, metal and ceramic composites. So continuous developments in aerospace ceramics is important in exploration of the space, aviation, aeroplane engines, shuttle tiles, rocket nozzles, all this. The continuous advancement in material science, ceramic engineer programs, all these are important to develop new technologies. Research also is important to develop all this, even small part of this. And everything is based on engineering and science and designs. Ceramics, I told high means high temperature, so hardness is important. Hardness because it should not wear out when it is at 1900 degrees centigrade. So it creates a dense and rigid structure. Okay, and can withstand means minus temperature 1900 degree when she entered, then immediately it will go to minus 60 70 when she landed in Florida ocean. So all these raw material are important for the production. All these engineers can enhance mechanical properties, fracture toughness, wear resistant and thermal stability of this all shuttles. Aerospace, next slide please. Aerospace industries, they demand stronger, lighter and more means heat resistant, more wear resistant materials for these vehicles. Nanotechnology is a breakthrough. eh? So all that chemical solutions, what suppose we apply tiles, all this on that. Earlier we will put suppose 10 mm tile. So ceramic density is also high, but lesser than metals. So that chemical solutions on nanotechnology based are being developed. So precision ceramic components through that CAD operation are being developed. So that all this that ceramic engineers are required. So new ceramic materials, production methods, properties of the products, components, strength, thermal stability, wear resistant, insulation, chemical, because it will go through high speed as well as different environments it will cross. So that chemical inertness, all these are required. All kind of engineers and scientists they work. Now ceramics being used in various industries, automation, aerospace, electronics, whatever your mobile whole that mobile thickness has gone down, this laptop thickness has gone down, all the whole circuit is being printed on ceramic alumina substrates. So substrate will be 0.2 mm full plate, a big plate of your mobile size, and layers will be kept and circuit will be printed on that. That is electronic ceramics. Energy is required. Bearings are of ceramics. Seals being used in means automobile as well as in space vehicles is made of ceramics. Cutting tools are of ceramics. Generally, suppose you see that grinding wheel is there. Like that, so many cutting tools based on tungsten carbide, boron, all those boron carbide, silicon carbide are there, refractories and thermal insulators, because whole circuit is being insulated for this space vehicles. So ceramic materials, I can say, are critical in enhancing efficiency, durability and performance across various industrial processes and applications, including aerospace industry. Next slide, please. So as I said, it was my topic was there, in NASA on 4th February. All NASA pupil means offline, virtually also, and here physically also were present in this, and it was my topic was energy efficient technologies in ceramic industries. They were trying to find out whether same kind of, so there was one point that in suppose in our crockery, sanitary ware, tile industries, suppose we say these are being loaded on some refractory kiln furniture, means furnace furniture for heating. So now that if suppose you used to make 1 kg of product, so you were using almost 12 kg of furniture to make that product to rest on that furniture and to push inside the kiln. So that 12 kg we have come down. So to get 1 kg product, you have to heat 13 kg. Every time 12 kg. So we have come down from 12 kg to 0.5 kg. So that much thermal mass we need not heat. So that was the point they got from my talk. And next slide, please. They have shown me, I can say, to so many labs I have gone, and they have full-fledged laboratories, and we can say I can say each single laboratory may have 15 to 20 crore rupees worth of equipment in one, and that kind of laboratories they have almost 80 laboratories, and so many reactors were there. All these things are there. So laboratory I visited, I am showing. So this, and all the pupils, this boy is from different country, this is from different country. Don't think that all are from US. Next slide, please. Yeah, this boy was from different country, and this just photograph. Inside we cannot take the photograph. There will be one person. I will not be left alone inside the NASA to walk here and there. And we cannot take the photographs inside. I have taken on the gate. And this was a photo they have that I have taken just a photo there for that astronaut uniform.
NASA.
Yeah. Now I have come that in 1971, you can go to the next slide, please. Next. Next. This photo I have taken outside NASA, that Jellin Center. And next to that is Ohio Aerospace Institute. This was first time I have given the talk in NASA main center. Earlier I have given the 2 times in 2014 and 2016. My talk were in Ohio Aerospace Institute. That is adjacent to this only. So it's like you can say that promotion. 2 times gave talk in Ohio Aerospace Institute, which is the supporting lab of NASA. And now I have got, this time they have invited me to main NASA. Next slide, please. I took a photo that I told that was in their gallery. So I took this photo in that this thing, just a photo, nothing, no other objective in this. Next slide, please. This was the space capsule. This I have taken photograph from the photograph. when it went to the space. So space capsule 3, astronauts went in 1971. So you can see in that this thing, three windows are there, and all this on these three beds are there. Beds means chairs, that resting chairs. That chairs will become bed as well as this thing. These are visible. Now, next slide, please. I will come to the next. This was the photograph that when this capsule has come back, and you can see that how much temperature it would have faced, and how wear and tear has taken place. Color has changed. Color has changed. And all these whatever coatings are ceramic, means carbon composites, ceramic metal composites, not ceramic and metal composites also will have the high temperature. So this is all worn out, this thing photo, it has been displayed there. And coating is there, ceramics is there, composites are there, tiles are there, and all these things are all are outside, and whatever circuit controlling this, all signals, electronic ceramic has means all that, it is like in a box, all electronic ceramic items are used. The means bearings, you can say, the engine parts, you can say, which can wear and tear. So all those are made of ceramics. So in 1971, they have used the different kind of ceramics, and after that you can say almost, we can say almost 50 years, it has further improved a lot, and weight has gone down. Next slide, please. This was the gate when, now this gate when Sunita William came to this, and when it was taken to other place, gate was very hard to open. They were struggling to open the gate. So this was 1971. This was they took photograph for me. Next slide, please. This is the launching preparations for this uh, space capsules and vehicles. Next slide, please. This was the ninth mission, and you see the design and out means outer appearance of the capsule in which they went and came. After coming back, this photo is not means after reaching back. So I don't know what is the condition. I may get photograph after some time. So they went in this one. But it is, you can come see how much development has taken place, and weight has reduced almost 20 to 25%. Next slide, please. Now, if I say I have covered this electrical, refractories, carbon, ceramics means branches, different angles. Earthenware, you see, terracotta, you see, glasses, you see, structural shapes you see in the building, cutting tools you see, abrasive you see, flooring you see, building materials you see, cement you see, all these are of ceramics branches earlier. Now ceramics also as need based, that also branches have lot of modifications in the names. You will see. Next slide, please. You see now when we see ceramic, we see, you take all the metals, and all metals, oxide and carbides, they come into the range of nitrides, carbides, oxides, they come into the range of ceramics, whatever metal. So now oxide ceramic is different, magnesium oxide is different, zirconium oxide, aluminium oxide, and alumina based. You see that Aluminium titanate is there, alumina substrates are there, silicate ceramics is different, all that. Even we see a glass. Now glass also, glass you know that is made by quartz or silica. So glass is also silica free glass has come up. Glass is being used for as a fertilizer. That is new patent taken recently 1 year back. Glass as a fertilizer, carbide ceramics, so many branches of ceramics have been distributed now, which we used to call as refractories, advanced ceramics, all that. So now it has gone name based ceramic items. Next slide, please. You see, traditional we know all why this I have covered already, cement, all that. Electro ceramics is there. You see whatever substrates I am telling. Now we are talking about that semiconductors, capacitors, dielectric, piezoelectric ceramics, magnet ceramics, because magnets are not easily available. So you need magnets everywhere for your memory of data. You need the magnets. So magnets are made by ceramic materials, which are called ferrites. Optical ceramics is there, single crystal ceramics is there, conductive ceramics is there, nuclear ceramics, aerospace ceramics, bioceramics, so many. Tribological ceramics is there, which is wear resistant, which can tolerate any kind of weather. Automobile ceramics is there. These are the all different definition, different branches are coming up on as per the need of the day to day. Next slide, please. Now I will tell you the major raw materials. Aluminium oxide. When we make the aluminium metal, so alumina is produced, and alumina is produced, so that alumina is the father of ceramics. So alumina is means known for hardness, wear resistance. So it is used for bearings and seals in the engine seals, which we use to rubber seal all those, but seals also are made of ceramics. It has electrical insulation, excellent thermal insulation, thermal resistance, thermal shock resistance, corrosion resistance. It can tolerate any kind of chemical there. Next slide, please. Carborundum, which we call silicon carbide. Silicon carbide is having high conductivity. It is important for all this space journey. So that silicon carbide composites, silicon carbide and metal composites. It has high thermal conductivity. So somewhere we need conduct. So heat should not go waste inside the engines. So all that is important. So refractories and furnaces, cutting tools, abrasives, semiconductors, which is now you will be hearing, suppose semiconductor parks, semiconductor technology are coming in big way to India. So this material is important. Fused, next slide is that. Next slide, please. Fused silica. See all this when we go from room temperature to high temperature, 1000 degree. Now see when this space capsule entered to the Earth orbit, that time its temperature was 1900 degree. So when you heat and when you cool, thermal expansion takes place. So all the materials are adjusted for thermal expansion also. That suddenly it will go to minus 80. Suddenly it will go to, maybe because speed is very high. So suddenly it will go to, it came and it was on 1900 degree. Then again when it came, it was minus 100 or minus 150. Then it came to room temperature. And everything was happening in very short time period. So fused silica is the ceramic material, fused silica, which has zero thermal expansion. You see, simple to you to understand, when railway tracks are made, so the gaps are left in between that iron slabs. That is for expansion. In heat, in summer, it will expand. In winter, in North India, it will shrink. So that kind of fused silica is having important for wavelengths are important in space journey. So it is good for wavelengths tolerance. It is transparent. It can take high temperature. It is good for thermal, means electrical insulation. It is good for semiconductor, laser technology can be used on this. All this fused silica is important. One more material. Next is zirconia. It is wear resistant, and this suppose we say that 2700 degree. Only one property I am telling. Yttria stabilized zirconia. So all the properties what I have talked till now, it has all those properties. Additional property is that it is used in that 2700 degrees centigrade. Till that it will have good wear resistant, thermal shock resistant. It has low thermal conductivity. It will not pass the heat inside or means so easily. So main point is 2000. All other properties are there. 2700 degree is the melting point of yttria stabilized zirconia. Next slide, please. Silicon nitride. Silicon nitride. Now I will not talk all these properties. Whatever I am talking, thermal resistance, toughness, hardness, uh, insulation, all this. And silicon nitride is good for making means components. It where friction is required in sliding applications. So this material is being used. So bearing in this, in turbine components and engine parts, few engine parts which have lot of friction are made of silicon nitride, another ceramic material. Next slide, please. Tungsten carbide, also you can say it is 3000 degree centigrade plus, extreme hardness, thermal conductivity is good. All the drilling applications, tools, mining equipment, wear resistant parts, few wear resistant parts, because it is very costly material. It has high density also. So all these parts cannot be made by tungsten carbide. Few parts are made of this, otherwise weight of the vehicle, space vehicle will go up. So this is also another choice of the material for space. Next slide, please. Titanium diboride is there, which is used for, means not purely, it is used for coatings on the surface, outer surface of the space vehicles, which can take the wear and tear, this thing. And coating earlier used to be tiles, then tiles are being coated by this. Now tiles thickness as per the technology advancement has reduced, and coating is being done by this kind of coating materials. It is chemically inert, corrosion resistance and wear resistant. Aerospace components which are means very means um, means heat producing components, those are coated by this thing, titanium diboride. Next slide, please. Now these are all wear resistant parts used in means different applications. of alumina, zirconia, all the tungsten carbide, all that are there. Next slide, please. Even seals you can see are there. These are the wear resistant another components. This thing you can see looks like metals, but these are ceramic and metal composites. This is there. Next, this another components are there for ceramic. Just I am showing photographs. Wear resistant, even knives and scissors have come out of advanced ceramics. Next slide. Then another, next slide. Wear resistant ceramic components. These are of alumina. All those metals what I spoke earlier are there for this all space vehicles and engine components. Next slide. This kind of components are there, and right hand side you can see these are ceramic and metal composites, and all surface is like mirror finish. Next slide. These also seals are there, and of different thicknesses. What you would have seen in four-wheelers, in cars and all this, when the mechanic opens, all are made of ceramics. This thing. Next slide. Now, whatever the ceramic components, all the electronic communication circuits are printed on this aluminium oxide based, what I spoke, 0.2 mm thin plates for our mobiles as well as for space vehicles. They and it comes into 1 foot by 1 foot, this thing, and it will be printed and it will be 10 layers are made. You can see the next slide, it is ceramic parts are being used. Black one is boron carbide, boron nitride, this thing, and white one is this aluminium oxide. And right hand side you will see inside, which the piece in last slide I showed, it is fixed inside. When this aircraft lands and you see the blades, fan and blades are made of ceramics. Next slide, please. In means some journeys that you see top wear resistant glass is there, this thing, and you see in radars when it goes, face of the radar is made of ceramic, this thing. So it is alumina also, and some other new developments. Even zirconia is being used for. So radums top, that notch, that pointed part is called radums, and it is made of ceramics because it faces lot of heat with the speed and wear abrasion, this thing made of ceramics. Next. These are another. I have tried to show that so many components are being used for this. These are also another ceramic components for this, and bottom you will see for circuit pull, means wire cutting, wire pulling, all that holes are made. This is bioceramic, which is used for that shoulder balls, and kneecaps are shown in this. This is bioceramics. Next. Now I'll come to the US market and opportunities. US, Germany, Japan, UK, China, South Korea, Taiwan. They have lot of industries in these fields. Okay. All these countries are feeder to the US market. NASA, you can say, and other applications like electrical vehicles, that thing. It is $11 billion in 2021 market, and worldwide it is $104 billion market. So $11 billion goes to US alone, and rest to all other countries. Now, in two means there is some mistake in this. It is expected to be $188 billion in 2029. This market. Now, I said father of ceramics is alumina. Even good quality alumina, zirconia, titanate, titanium oxide, all those raw metals which I spoke, we depend on other countries. These quality of raw materials which are required for this component development are being imported. Now, 7 factories with the investment of 265 crores on advanced ceramics are opened up in Telangana. There is a medical devices park and they are taking shape. Then maybe in another 2 years we can count of some share of our country in these components. Next slide, please. USA, now I will say USA has 11 companies in this field. UK has 2 companies, means organized sector I am telling, not the MSMEs. Japan has 4, Germany has 3. So, but in India, we are no organized big company. Another this whatever in Hyderabad coming up, and there is one Anant Technologies in Telangana only. That is one company, organized company. Otherwise, carborundum is there, but not into carborundum Hosur plant, but not into all these applications. So that is one and two. 2 companies are, we can say, in organized sector, other all or small scale and micro and all that. So all these companies, so and that 2 organized sectors also not into that all this very sophisticated components production. Next slide, please. So this is my presentation. Now I have covered that what is the importance of all scientists with the background of physics and chemistry, mathematics, what is the engineers of different branches, and particularly now all the branches engineers means all are important, but this space mission cannot be completed without ceramic engineers. So that is my conclusion here. So thanks a lot for patient listening. Now over to you, please.
Thank you so much for this very, very informative and enriching presentation, sir. It is very interesting to see how the ceramic compound and the images which you related it with the application was very, very interesting and enriching for us. The entire audience would have been greatly benefited. The floor is open for questions for 5 minutes, and any other questions which go beyond 5 minutes, we will take it in the chat box and we will reply to you via mail. The floor is now open. So any student who wants to ask any clarification, any question, please go ahead. Any questions?
Professor, can you share information about the online course? We have about 10 students who have enrolled.
Yes, yes. That's after giving them time if they need to interact anything with the Sharma sir.
No, let them ask questions, then I will tell this thing. In 2 minutes, we will wait. If
Yes.
someone has some question.
Sir,
You
if
can
I can
raise
ask, sir, there was a question from a professor in SRM University with whom we interact very closely. That professor was asking why new ceramic industries are not coming up very fastly in India. Do we have an answer for that, sir? He said that ceramic industries are not coming up in the advanced ceramics, but while in traditional ceramics we have a good market, in terms of advanced ceramics, he said not many companies are coming up. The silver lining is what you mentioned about what is happening in Telangana, but then can we have more
I
companies
will tell
coming up?
you. We have the big population. Our government also and we people also,
Yes, sir.
they are concentrating on consumable market. So
Okay.
traditional ceramics, tiles, all that. And
Yeah,
we
yeah.
are in worldwide, after China, we are number 2 in tiles production
Okay.
in the world. But not even if we compare China, China is on that high productivity. So that is one thing. Second thing, in advanced ceramic component industries, we need some very, I told that raw materials which we need, that
Yes,
raw
sir.
material industries are not available in India. So we have to import, that cost will go up. Number
Right.
3 point is that all these advanced ceramic industries, they don't generate big employment. They don't generate.
They
So
don't.
those companies, so for that region, we look for labor oriented job, and you need lot of automation, robots working in the industry. So that kind of regions not means that this industry is not come on, but it is coming up because we
Okay.
need this all this.
Yeah.
Yeah, yeah,
So there were two questions. One was a student
See,
wanted to know how to join in the research sector, and another question was on bioceramics.
yeah. No, now whoever wants to do enter into this aerospace industry, you, as I have told, you should be good for in means mathematics, physics. You should be good, and whatever I have talked about that skills, which in 2 or 3 slides in the beginning I told, you will be going through tough interview in first stage, second stage. So those skills are important. If suppose you want to go to US, you should know English and you should pass some tests after graduation to get the scholarship. So to get into the aerospace industry, all of you, maybe from different background branches, you can enter if you have all these skills and knowledge into depth, you can enter.
there is a
Yeah,
specific question on bioceramics, sir. Does
yeah.
bioceramics have the highest and can they withstand high temperature, and what will be its strength on Mohs scale?
No, bioceramics will be, suppose we see that there is one dental ceramics. Dental ceramics, whatever our tooth hardness, suppose we say it is between 5, 5 to 6 on Mohs hardness. Now tooth are made of porcelain. So if suppose earlier metal tooth were being fixed, now it is now zirconia tooth, all that. So hardness is maintained on the same level only between 5 and 6 for the dental ceramics. And now for this bioceramic, whatever I spoke, the bioceramic components for solder joints, all that, hardness is kept around 7 only. It is not. That materials will be used, but hardness will be brought down so that it can be biocompatible in our body. So that will be the thing. And people who are interested to enter into bioceramic field, so you can do BTech, you can do MTech, then go to advanced ceramic part. You can go then bioceramic, you can go to bioglass as well as bioceramic this thing, and then you can do research on this bioceramics PhD or something, and then scope is there is only 2 companies in India on large scale organize this things sector. One is in West Bengal and one is in this Karnataka. So those two companies are manufacturing bioceramic components. Earlier, whatever that kneecaps, all that were of metal, and metals were being found that these were not so easily biocompatible. So that way you can enter into bioceramic field. Yeah.
Thank you so much, sir. In the,
Now,
any other questions? We will take it from the chat box and we will ask sir the answers via mail. It will be answered, students. So thank you so much, sir.
now I will come to
yes.
that. Whoever these people are attending here, almost 50 people registered, and we explore the space that Mr. Venkat and team, they have initiated a course on this. What is that topic? I forgot just. Yeah, that course
It's
is there
career,
on. Yeah, which
career
topic?
opportunity in space and allied industries.
Yeah.
And for every sector, a special need. And for them, it is ceramics in space.
Yeah, so that is there, and that some lectures will be there, and explore the state. This organization will send you the homework literature to go through that. Then you can study that literature. Then there will be the test. You can you can there you will get opportunity to appear for the test. First time, if you go at 70 or 80% plus, then you will immediately you will get the certificate. You will be given another chance to go through the literature and again reappear in the exam on the test. Everything will be online. So you will be again you will have chance to improve your performance and grading or marks percentage. All the participants will be given this certificates, and for all this literature sharing, and there will be online classes also. Lectures will be there from 4 or 5 lectures, I don't know exactly, will be there for you pupil free of cost. So for this whole course, there is 1,500 is the participation fee to get the certificate. And I am 100% confident you will learn lot of new things. And I have visited the laboratory of this Explore the Space. You will, whatever things maybe you graduate engineer and PG or PhD, the way science is being displayed and shown in this their laboratory is so simple that even school students can understand that, and there that big principles of science. So that way you will learn so many things here, and I have not entered into the depth of this my subjects here. I have also touched the highlights of this and tried to make this lecture very interesting and adding with so many photographs. So you, all of you, my advice, I will not say my advice, and I can request all of you to join that course. And I am also I am live member of their Explore the Space, this organization. So I can request on behalf of them. Yeah, thank you. Next. Yeah.
Thank you, sir. Over to you, Professor Sumitra.
Thank you so much, sir. I just need to
So,
share a small presentation regarding Explore the Space, ETS, much of which sir has already spoken about the course. So I think I'll just, flash the slide for a while on the screen and tell whatever is bare minimum essential about Explore the Space, fondly known as ETS. You can share the Full screen? Yes. So this is thanks to Sir's wonderful webinar. Can we go to the next slide, please? Next slide, please. This is just a sneak peek into ETS, the slide before. The slide before. We started in 2016, and we are an Niti Aayog registered space tutor, and we are ISRO's registered space tutor. And when this entire thing was conducted, we were the first to receive it in India. And we work with a mission telling space education for youth all over the world. Space unites the world. Next slide, please. And Explore the Space, we have connected to nearly 7,000 students across geographies in near to 100 plus schools and colleges, 25 plus industry, both public and private sector in all Indian states, and a lot of, the other continents outside Asia as well. And we conduct workshops on STEM experiments for both school students in Chennai as well as rural areas. And we are known for our very active quiz programs. And we had a wonderful lecture series, just to name a few, Raman Armstrong lecture series, and international webinar series on future of space technology and exploration. Next slide, please. Okay, about this course, Sir has already spoken about it. The entire course content will be a digital study material, a webinar, an objective test, a certificate, and a lot of networking opportunity. When you see this course, you will understand that whatever we have put in together is by a big team effort of lot of experts, and you might have to go through at least 200 books to see what is there in our course material. So everything is there in a nutshell. So please make very good use of it, students. Next slide, please. This is the college, course material. It has a part A and part B. We deal with both the technical material, which is essential for the basics of space technology, and also the other, things that are required for the market, interview skills and personality development, which is all covered in part A. Okay, please go to the next slide, please. This next. This is a sneak peek into our expert team. Okay, this is Mr. Tim Dyer, President, Maxi Innovation USA. Mr. Jaydeep Mukherjee, Director, FSDC NASA. This is me. Next slide, please. We also have another professor called Shakila Devi, who's senior tutor, and Mr. S. Balagurunathan. He is a science expert, an NCERT book writer, and a retired government teacher in a very great government school, principal also. So he's like one of our backbones. Next slide, please. So students, we are in this forum. We know that already 10 of you have registered into our course. The rest of you, please make good use of it, and be sure you'll be benefited. Thank you so much to all the audience, and a very, very special thanks to Dr. L.K. Sharma, sir. Thank you for all this time.
Yeah.
And
Thank you so much,
Thank
Dr.
you.
Sharma.
Thank you, Venkat. Thank you, Professor
Thank you so
Sumitra.
much.
And thank you all the participants. Please come and join.
Yeah, we would like to discuss more about certain internship opportunities, for which we will come to you very soon. And on behalf of Explore the Space, we thank all the participants, and a special thanks to Dr. Sharma ji. And we hope to meet all of you very soon. Thank you all.
Thank you. Thank you.
Thank you all.
Good night.
And good night, all of you.
Good night.